Today we are going to talk about conservation of energy. As you have learned already in class, energy conservation is key to the universe. Energy cannot be created nor can it be destroyed, but it can be converted from one form into another. In today's demonstration, we are going to look at how energy is converted from electrical potential energy in a battery to rotational energy in the gears to gravitational potential energy through the chain to kinetic energy as the carts go down the track. What you're going to see here is that as this cart goes up the track, it is going to get pulled up by the gears and the chain, and that is due to the batteries converting chemical potential energy. When it gets to the top, the cart comes gliding back down. Now, I'm going to go through this very slowly with you so that you can see the various steps of this energy conversion. And we could talk about how potential energy specifically is converted to kinetic energy. I'm going to stop the motor so that we can see this. So what is going to happen is this cart is going to come down the track, and when it gets to this point, it will come through, it's gaining kinetic energy. There was gravitational potential energy at the top, it's speeding up. When it gets to here, it's going pretty fast. When it comes through this loop, watch it. It will slow back down because it's going back up, gaining additional potential energy. And then that potential energy is converted along with any remaining potential energy from the top back into kinetic energy. I'll just manually push this up. My chemical potential energy, the food I ate, is helping give this cart the gravitational potential energy. Here we go. Watch the cart slow down. Now, what we can really see it slow down by stopping the cart so that we have taken out the additional potential energy at the top. Now, watch what happens when I release the cart at this point, below the top of the loop. It doesn't go through because there's not enough energy to get back to the top. The cart, at best, is going to return to the same height that it left. I'm going to start a little bit higher, and it's still not going to get through. I'm going to be really quiet. Hopefully we can hear this on the video, but you should hear some noise being created by the wheels as they're going down the track. That noise is energy, sound energy. There's also some friction. If we measure the temperature of the track with very precise instruments, we'd find that the track's temperature also increases slightly. So there's lost energy from this system. When I pull this back up and I release it from up here, now I've given it some extra potential energy to overcome the friction and sound, and now it goes through. And you can see how slow it was going right at the top. Let's watch that one more time. So I release it from right about here, and it's almost stopped when it reaches the top. And that's because the potential energy, gravitational potential energy, is converted into kinetic energy, some frictional heat, and some sound. And so that sound and heat is non-usable. It's called non-conservative energy. Non-conservative forces pulling the energy out of this system and putting it into the universe as a whole. And then that energy is not able to get converted back into gravitational potential. The energy, as this goes through, it reaches the top, it's almost stopped, it then keeps going down the track. The same thing happens with the cart on the back side. It will go up to the top. When we release it, it will speed up. Watch it come over. I haven't calibrated this today, so it actually might be a little low. I can adjust its position so to make it go faster and slower over this, but it comes back up the hill, it'll slow right down. Watch it happen. Almost stops right there. And that's, again, the same example. Why did it stop here? Well, the track wobbled and there was, again, some lost energy. But you could see it as it came out of here, it got up, it slowed down, and again, we're seeing gravitational potential energy getting converted into kinetic energy and then back to gravitational potential energy, but with not the same amount of potential energy we started with because some is lost to the surroundings. If you have any questions, as always, please let me know. I hope you enjoyed this video. Have a great day.